So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the key word for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. So today we're going to be talking about lesson number 8, which is basically on percent error and change. Our aim for today is going to be how can we use the formulas and our knowledge of percentages to calculate percent error and change. This is the last lesson for Unit 3. Again, let's go over some important vocabulary before we go over the concepts and the formulas that you need to know. Percent change is going to be a ratio that compares the change in value to the original amount. So essentially you're finding out the percent of the increase or the decrease between the two numbers that are given to you or that you want to find the percent change for. Our percent error is the difference between the estimated and the exact value as a percent of the exact value. So you're comparing it again to the exact value or the actual value, the actual amount, whatever you're talking about specifically about in the problem. So percent error is essentially the percent of how wrong you were on a guess. So you're estimating, you're guessing a value versus knowing what the actual value is. So in order to find percent change and error, they're very similar, but percent change, you want to find the difference over your original amount. So whatever you started with, you want to make sure that's going to be in your denominator. The difference between what you started with and what you ended with, that's going to go here in your numerator. So you want to find that difference first. Again, setting up as a proportion, you have equals percent over 100. If you have an equation, you're going to find the difference over the original, multiply that by 100, and then you're going to get your percent change. For percent error, you have estimated and exact values. Again, you're finding the difference between the two of them. You want to make sure that it's a positive number in the numerator. Again, if you have a positive number, if you don't use absolute value, a positive number is going to be an increase. A negative number is going to be a decrease. So the percent of the difference. So for your percent error, you have estimated and exact. You want to find the difference between the two of them. You might have absolute value. You might not have an absolute value around it. It's up to you. You want to make sure that you have that number a positive value. Again, you can keep it not with absolute value, and that positive or negative is going to tell you whether it was a percent error above or below what it should have been. So again, it would be completely up to you as long as you understand what those numbers are going to represent in percent error. So we want to find the difference between your estimated and exact over your exact. Again, either way you could write this, you have the same thing. You're finding the difference over exact, but then the second part is where it's going to change. So for proportions, you have equals percent over 100. Equations, you have times 100 equals your percent error. So that's just the difference in the setup for percent error when you have your proportions or your equation. Again, you can just substitute difference up here if you need. Let's try. So let's go into number 1. For number 1, Sally grew over the summer. She was 55 inches, but now she is 60 inches. You want to find the percent change. So we have the difference between the two over the original amount, or the original value, let's equals percent over 100. So we have 55 minus, or let's do it the other way. Let's do 60 minus 55 over the original, which is 55. I'm changing my percent to an x, so I know I have a variable. So you have 55 times x. And then we have the difference, which is 15. So 15 times 100. So I'm going to move this over. We have 15x equals 1,500 or 1,500, We want to isolate our variable, so we're going to divide both sides by 55. I'm going to get x equals 27.27, and it repeats. I want to make sure I'm rounding to the nearest percent. So my nearest percent is going to be 27% change. And in this case, if I needed to describe what type of change it was, I'm going from 55 inches to 60. So that means I'm growing. It's a positive. So it'd be a 27% increase. All right, let's try number 2. Pause the video, try number 2 on your own, and come back and check your answer to see if you're correct. So here we're trying to figure out percent change again, but now we're given that Dennis is moving from a house that is 32 miles away to a house 32 miles away from work to a house that is 18 miles away. You want to find the percent change. So we have to find the difference. It's 32 minus 18. We want to compare it back to the original, and let's use the equation. So equals 100 times 100 equals percent change. Okay, so 32 minus 18, we are left with 14 over 32. We're going to just rewrite everything. Now when I calculate 14 divided by 32, I'm going to get a decimal. My decimal is 0.4375. I'm still going to multiply that by 100, and that's going to give me my percent change. And in this case, my percent change is actually going to be a percent decrease, because I'm decreasing the distance between work and home. So my answer, it doesn't say it around, but it's going to be 43.75%. Or you can even write as a fraction, 43.75%. That's what kind of change it is, and it's a decrease. All right, let's try number 3. Pause the video here. Identify the fact that you're going to find percent error, and you're rounding it to the nearest hundredths place. Pause the video, try this on your own, and come back and check your answer. Okay, so we are told in this problem that we have the estimate was 2,000 students in 73, but there's an actual amount of students of 2,175. So that is what we're going to be comparing it to. So that is our actual amount, 2175. Set up our proportion. We have 2175 minus our 2,000 students, the difference. I know it's going to be 175 difference in comparison to our original, or the actual, I should say, is 2175. I'm setting up my proportion. I'm cross multiplying. So I have 2175 as x equals 175 times 100. Not 1,000, it's 100. I get 2,175x equals 17,500. And again, I want to isolate my variable, so I'm going to divide both sides by 2175. My variable is going to equal 8.0459 ... And again, I want to round to my nearest hundredths place. So if I'm rounding to the nearest hundredths place, that means I'm going to go to this decimal, my 4. My 5 is going to help me bump my 4 up. So I have 8.05% error. And that's my answer. Again, finding the difference in comparison to the exact number of students in the school versus the guess. And I got 8.05% error. Make sure you are writing down any questions that you have for me. Make sure you're identifying your keyword and phrase. And I will see you guys in the next video. Bye.